So we'll do a second or a separate video here for your second derivative of implicit differentiation. So first of all, you got to figure out your original derivative before you can figure out your second derivative. So just normal power rule here. Put the exponent in front, decrease it by 1, then you'd have to do times the derivative of the inside, which would be a dx over dx, which is 1. Oh, cool. Look at that. We've got variables times variables. Product rule. Woohoo! So, after the subtraction sign in parentheses, derivative of the first times the second. So derivative of x is 1, technically times dx over dx, but that's still just y, plus the first x times the derivative of the second, which would be 1, but the inside would be dy over dx, which is a y prime. And then we could do the derivative of y squared, which would be a 2y. Then we have to do chain rule, derivative of the inside, derivative of y with respect to x. So dy over dx or y prime. Derivative of the right side, derivative of a constant is 0. There we go. Well, all we have to do now is go ahead and solve this for y prime. So get rid of the parentheses, get all the y primes on one side, get the non-y primes on the other side. So I'm going to go ahead and take this and this, leave them on the left. I'm going to take my 2x, subtract it to the other side, take my y and add it to both sides. So I get this, factor out my y prime, then I can get y prime by itself by dividing by the parentheses. Cool. Well, that's not too bad to do my first derivative. Now I just have to do my second derivative. Look at here. I got variables divided by variables. Ah, quotient rule. So, quotient rule says derivative of the top, derivative of y is y prime, minus derivative of this would be a 2, technically a dx over dx, which is just 1, times the bottom minus the top times the derivative of the bottom. 2 times derivative of y with respect to x would be a 2y prime, minus a 1. Technically, it would have a dx over dx there, but that's 1 over the bottom squared. Now, this is my second derivative, but I need to simplify this down, and I got to write it with only x's and y's, not any y primes like I have in here. So we're going to go ahead and do that. I'm going to go ahead and FOIL out the blue. Beep. I'm going to FOIL out the red and distribute through the negative onto the red. We get this. Ah, well, then we could go ahead and collect like terms. You'll notice we have a few like terms here. Beep, 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 beep. And and So collecting all those like terms, we just get this. That's not too bad. So I'm going to go ahead and plug in what y prime is here. Y prime is, oops, that's not what I wanted to do. Y prime is what I have right here. So I'm going to take this whole thing up here, and I'm going to go and take this whole thing and plug it in right there. So I'm going to still have my 3x, my 3y, and this here. And then instead of writing that circled in y prime there, I write that fraction up above. So I get this. Okay, so now all we have to do is simplify that because we have fractions within a fraction. Notice this is a 3x over 1 times it by this. So 3x over 1 times that. I just 3x times the top, 1 times the bottom. It doesn't change it. This is a 3y over 1. So now we could do a couple of things here, but what I'm going to do is I'm going to multiply the top and the bottom by the common denominator of the top, which is just this. So I'm going to multiply the top by that. And if I multiply the top by that, I got to do the same to the bottom because I can only multiply by special forms of 1. So now, when I take this and distribute it onto this first fraction, it cancels out my denominator. And then I'd also have to distribute it onto here. So distributing this onto my first fraction cancels out the bottom, minus my 3y, take this and apply it right there. The bottom, it's the exact same thing. That one's squared, that one's to the first, so it's really just being cubed on the bottom. So now we just have to go ahead and try to get rid of the parentheses, and if we happen to have some like terms, combine like terms. So we'll go ahead and distribute through our 3x, distribute through our negative 3y, making sure you distribute the negative through. You'll notice here we have a 3xy and another 3xy. Those are like terms. We can combine those together. Now, this is really your second derivative. But in this particular case, not always, but in this case, and sometimes I would say in about half the cases, it's going to simplify farther yet. And you might be like, how? There's no like terms. Well, yes, but I'm going to pull out a negative 6. So if we have that, now remember, your original problem was an x squared minus an xy plus a y squared is equal to a 9. So this whole red thing right up here, you could replace with 9. So the top's your negative 6 times a 9. Wow, we know negative 6 times 9 is just negative 54.